Welcome to The Explainer. Have you ever stopped to wonder why that jar of pickles seems to last like forever, while a fresh apple goes bad in just a few weeks? Well, today we're diving into the incredible science of food preservation. It's a microscopic war happening in your kitchen right now.
So, let's start with a little puzzle. How is it possible that a fresh apple can spoil in a matter of weeks, but another form of that same apple, say a dried apple ring, can last for months, maybe even longer? The answer is all about the ancient art and, you guessed it, the modern science of keeping our food fresh.
To really get to the bottom of this, we first have to meet the bad guys. These are the culprits of spoilage, the unseen enemies that are constantly trying to reclaim our food for themselves.
You know, what we just call spoilage is really a full-on microscopic battle. There are millions of tiny microorganisms. We're talking bacteria, yeast, and mold, and they are always at work. They produce these acids and enzymes that break our food down, and that's what leads to that awful smell, or that weird fizz, or, that fuzzy green stuff.
Okay, so why bother? Why do we put so much effort into fighting this invisible war? Well, it's about way more than just avoiding a smelly fridge. It's actually a critical technology, and it has some major benefits that have pretty much shaped our entire modern world.
I mean, think about it. Preservation lets us enjoy seasonal foods like mangoes all year round. It means we can ship food all over the globe to places where it doesn't grow, and we can store it super efficiently. It cuts down on waste by dealing with extra produce, and, maybe most importantly, it locks in the food's nutritional value.
Now, of course, not all food is created equal in this fight, right? They fall into different categories based on how long they can hold out. You've got your perishables, like fresh milk or meat, which spoils super fast. Then there are the semi-perishables, like cheese, which can last a few months. And then you have the champions of longevity, shelf-stable foods like cereal grains or canned goods, which can last for over 6 months, all thanks to some really effective preservation.
All right, so how do we actually win this battle against spoilage? Well, you need a strategy, a playbook, and this playbook is built on a few core principles that we've been fine-tuning for centuries. At the end of the day, the goal is pretty simple. We have to control all the things that cause spoilage. That means managing the natural enzymes in the food, keeping away pests like insects and rodents, and preventing physical damage. But the number one target, our main focus today, is stopping those tiny microorganisms dead in their tracks.
Okay, this is where it gets really cool. Let's open up the toolbox and look at the actual weapons we use to pull this off, from tricks that are thousands of years old to cutting-edge science. Our first weapon is temperature, and we can use it in two totally opposite ways. Low temperatures, like in your fridge, that's basically hitting the pause button. It just slows down microbial growth. High temperatures, on the other hand, like pasteurization, well, that's more like hitting the delete key. It destroys the microbes for good.
Next up in our arsenal, chemicals. And I know what you might be thinking, but hang on. This isn't as scary as it sounds. We're not talking about weird lab concoctions. We're often talking about weak organic acids, many of which are totally natural, and they work by making the food's environment a really hostile place for microbes to live. And what's so clever about this is that it's not a one-size-fits-all solution. Different acids are like specialists for different jobs. You've got acetic acid, vinegar, which is a bacteria's worst nightmare in pickles. Propionic acid is often added to bread to fight off mold. And sorbic acid, it takes on yeasts and molds in things like drinks and dairy. It's a really targeted approach. So how does this acid thing actually work? It's honestly genius. It's like a tiny Trojan horse attack. The acid molecule, in its neutral form, just slips right past the microbe's cell wall. But once it's inside, where the pH is a bit higher, it releases a proton, which makes the inside of the cell acidic. The microbe completely freaks out and uses up all its energy trying to pump these protons out, and eventually, it just exhausts itself to death. Game over. Okay, our third weapon is one of the oldest tricks in the book: dehydration. This method is all about reducing something called water activity, which is just a fancy way of saying the amount of available water that microbes can actually use. You can either remove the water directly, like with dried fruit, or you can tie it all up by adding salt or sugar.
See, when you suck all that available water out of a food, you create something called osmotic shock. Imagine your little microbe cell. Suddenly, the world outside you is like a desert, and it's much drier than you are inside. So all the water from inside your cell just rushes out to try and balance things. The poor thing just shrivels up, which either kills it or forces it into a dormant state where it can't do any harm. So temperature, chemicals, dehydration, what's the big takeaway here? It's that this isn't just some high-tech stuff happening in a factory. This is a science lab, and it's happening in your kitchen every single day.
Think about it. Your fridge? That's a low-temperature preservation device. That carton of milk lasts a week instead of just a day because the cold is hitting the pause button on all that bacterial growth, just like we talked about.
And that jar of pickles sitting in your pantry, that's a chemical preservation system in action. The vinegar's acetic acid has created this super acidic environment where most spoilage bacteria just can't survive. It's that perfect Trojan horse attack. And that bag of beef jerky you love? That's a total masterpiece of dehydration. It's the perfect example of how just removing water denies microbes a place to grow, and it creates a food that's perfectly safe and stable for months.
You know, when you boil it all down, all this cool science, from temperature control to chemical warfare and dehydration, it all serves one simple ancient purpose. And this quote just says it perfectly. The meaning of preserve is to keep safe, retain quality, and prevent decomposition.
So now you know the secrets. You'll never look at a can of soup or a bag of dried fruit the same way again, right? The real question is, what other everyday science are you going to find hiding in your kitchen?